Okay, so this section 9.4 is talking about evaluating inverse trig functions by hand, okay? So remember, if you see an inverse sine or inverse trig function, it either has the word arc sine in front of it, or arc whatever the trig function is, or that trig function to the -1. Those two things mean the exact same thing, right? Okay, so if we're talking about an inverse function, and in order for a function to have an inverse function, it has to be 1-to-1. This was back in like algebra 2 stuff. In order for a function to be 1-to-1, it has to pass the horizontal line test, okay? Now, if I look at this graph of sine of x, does sine of x pass the horizontal line test? No. So what some mathematicians back in the day decided to do is they decided if they defined that sine of x is on a restricted domain, then it would be 1-to-1. Okay, so this red piece right here, I'm going to kind of box it out. This red section of the graph, okay, just that little curve, this piece is now 1-to-1. If I drew my horizontal lines through, I'm only going to touch one point, right? So if I were to write the domain and range of this piece that I highlighted in red, my domain of this function would be from, negative pi over 2 to positive pi over 2. And my range would be from -1 to 1. Do we agree? Okay. Now, again, if you remember back from algebra 2, the big idea of inverses, if we're switching, or sorry, if I want to find what the domain and range are of an inverse function, what do I do with the domain and range? I flip them, right? So my inverse of sine, the domain is actually -1 to 1, and then the range is negative pi over 2 to pi over 2. Okay, also just a good thing to note here, this inverse of x does not equal 1 over sine of x. Okay, so don't mess that up when you're solving things. Those are not equal to each other. Okay, so that graph of arc sine of x is shown right here. That is just this piece, because otherwise it would not be a 1-to-1 function. Okay, the main thing that you need to remember though from this page is your arc sine, domain, and range. Okay, moving on to the next page here. Okie dokes. Again, this is just your definition in words. I think a lot of us are probably visual learners, so I'm going to go ahead and draw a picture of what this means on our unit circle. So if I've got my coordinate plane here, and I've got my unit circle, okay, I don't know how to make it not be filled in. That's okay though. I'll just draw the lines on top of it. Okay, so if we're talking about arc sine is defined in the first and the fourth quadrant. That's what that domain of negative pi over 2 to pi over 2 is telling us, or sorry, the range. So from negative pi over 2 to positive pi over 2. Okay, so when we're evaluating an arc sine, it has to fall within this range, okay? I'm not going to have, if you look at your unit circle on your gold sheet, I'm not going to give a value of 5 pi over 3. 5 pi over 3 is technically in this quadrant, and it goes all the way around. Instead of saying 5 pi over 3, we would just say negative pi over 3. It has to fall within that range of negative pi over 2 to pi over 2, okay? So your answer always has to be for arc sine in either the first or the fourth quadrant. Okay, so if I look at this first equation or first example, it says find the exact value of sine inverse of -1. So the question that you're asking yourself basically is what angle in quadrant 1 or quadrant 4 has a sine value of -1. Okay, so if you look at your gold sheet, in between negative pi over 2, pi over 2, where is the sine value or the y value equal to -1? Where's my y value equal to -1 of all those coordinates on your gold sheet? Right. So this technically down here at this point, that coordinate point is 0, -1, right? So the y value is -1. So then I'm actually finding the angle to be negative pi over 2. That's included in my range, whereas 3 pi over 2 is not. Okay, even though, yes, it's the same value, it's not that same angle in that range. Okay, so I need it to be in between negative pi over 2 and pi over 2. Another way that you can think about writing this is that if we had something like y is equal to sine inverse of, we'll just call it x, this is your ratio, and the answer you're getting is your angle, okay, from your unit circle. So the stuff on the inside is like the value of either that x or y over x, and then your angle is what you're getting out as an answer, okay? Okay, let's look at this next one here. This next one says, what is the exact value of arc sine of -1/2? So again, I'm looking at in the first and fourth quadrant, what value is going to give me a -1/2 for sine? I heard 11 pi over 6, and I heard negative pi over 6. Which one is going to be in that range of negative pi over 2 and pi over 2? The negative pi over 6. Okay, even though, yes, they're the same thing, technically, this angle of 11 pi over 6 has to go all the way around to get there, whereas this is actually included in my range. Okay, so your answer for this one would be negative pi over 6. Okay, last one, sine inverse of square root of 3 over 2. So what angle in quadrant 1 or quadrant 4 is going to have a sine value of square root of 3 over 2? Sine is your y. What'd you say? Pi over 3. That's exactly right. So this angle right here, pi over 3, has a coordinate of 1/2 square root of 3 over 2. So yes, my y value is in fact square root of 3 over 2. So this would happen at pi over 3. And pi over 3 is in that range from negative pi over 2 to pi over 2. So that is sine. Sine inverse happens in quadrant 1 and quadrant 4. Okay. If I look at the cosine function starts at 1 on the y-axis, which means that my domain and range are going to need to shift a little bit. It can't be the exact same, because if it was the exact same, would this pass the horizontal line test? No. So instead, they shifted it over, starting at 0 and going over to pi, which means that my domain and range for cosine, this is for cosine, domain would be from 0 to pi, while my range is from -1 to 1. Okay, so that means that if I'm looking at my arc cosine or my cosine inverse, they mean the same thing. My domain is from -1 to 1, and then on the next page, my range is from 0 to pi. So again, here's my graph of just arc cosine, that restricted domain. And then here it is written in words, your definition of your inverse cosine. And then if I drew a picture of this, got my unit circle, okay, for arc cosine, oh, I forgot to see there, arc cosine, this has to happen in the first and the second quadrant. Okay, arc sine happens in the first and the fourth, arc cosine happens in the first and the second. Okay, so again, I'm going to write out the question that you're going to ask yourself when you're solving these because I think that helps a little bit. You're asking yourself what angle in quadrant 1 or quadrant 2 gives you a sine value, cosine, a cosine value of 0. Okay, so looking on my unit circle here, the shaded region is where my answer has to be. Where is cosine going to be 0? My x value is 0. Pi over 2. This value right here is at the coordinate point 0, 1, right? So my cosine inverse of 0, give me an angle, pi over 2 would be your answer. Okay, my next one, we've got negative square root of 2 over 2. So where on my unit circle am I going to have negative square root of 2 over 2? What angle am I going to get? Negative pi over 4. Oh, you're close. It has to be in the first or second quadrant. So that value would be at 3 pi over 4. Okay, and that coordinate point there is that negative square root of 2 over 2, square root of 2 over 2. Okay, yes, it is still going to give you, well, no, actually, your other negative cosine would be in this quadrant here, but that's not in my domain of our cosine, right? So I'm only going to take that answer of 3 pi over 4. And then go ahead and do example 6. I think you guys can figure that one out. What angle is going to give you a cosine value of negative square root of 3 over 2? Did we get 5 pi over 6? Yeah. Yes? Very good. Okay, next is inverse tangent. This is my graph of tangent. Okay, so if I wanted to restrict it to make it a one-to-one function, I would have to restrict it to just one of these periods where my normal domain of tangent is from what to what on that graph? Negative pi over 2 to pi over 2. And we put parentheses around that because why? There's asymptotes, right? Yep. So I can't actually touch the value at negative pi over 2 and pi over 2. And then my range, that's my y values. So that's all the way from negative infinity to positive infinity. So if I'm looking at the inverse, that means we're just flipping it. The domain is therefore then the range, so negative infinity to infinity. And your graph is below, which that makes sense. My domain here is from negative infinity to infinity. And then my range is from negative pi over 2 to positive pi over 2. And if you look at your graph here, that is in fact what these values are, except they're at like negative 1.79 or the negative pi over 2 value. Okay? That is my definition in a bunch of words. However, there is a few typos here. I need to cross out these little lines underneath infinity and negative infinity because I can't actually reach those values, right? And then same thing at pi over 2 and negative pi over 2. Those values are also not reachable. What do I need to change about my interval notation? If I got brackets around negative infinity and infinity, those should be parentheses. And then negative pi over 2 also should be parentheses. Okay, and then this will be my arc tangent picture. And arc tangent happens in either the first or the fourth quadrant.
How do you know,
So, if we look, we're asking ourselves what angle has a tangent value of 0. So tangent, remember tangent is y over x, right? Or your sine over your cosine. So what value in this blue region, first or fourth, is going to give me a tangent value of 0? What angle? Is it pi over 4?
Is it?
I'm asking.
I'm asking you.
Pi over 4. If I did y over x, that would give me 1, wouldn't it?
Oh.
But I want 0.
Yeah, I wasn't listening. 0.
So 0. This coordinate point would be 0. Nope, that's wrong. That would be 1 comma 0, right?
No, wait, so
That coordinate. So if I found tangent is y divided by x. So this is 0 divided by 1, and then I do end up getting 0, right? So your tangent inverse of 0 is just 0.
Oh, because the 0.
0 divided by 1 is 0. Okay. If I asked arctan of -1, so that means in these two quadrants, what am I going to get, or what angle is going to give me a tangent value of -1?
That does not feel possible.
It doesn't feel possible? If you look at your x's and y's and you start dividing them,
7. Because like -1 over 0 is not. Wait, does that?
you're right. But if I look at that coordinate point right here, this is the square root of 2 over 2 and negative square root of 2 over 2, right? If I take my y and divide by x, what do I get? -1. Now when I label this coordinate, that angle is not going to be 7 pi over 4 because that goes all the way around. It's negative pi over 4. All right, last one here. Again, tangent, that is going to give me a negative square root of 3 over 3. So what angle is going to give that to me? Also think about this is the same thing as tangent inverse of -1 over the square root of 3, right? Because I could get the square root of 3 over 3 by rationalizing that. So I got to look at my unit circle, and I got to look at what angle is going to give me a -1 over square root of 3 for tangent. So that's my y over my x. That's going to give me a -1 over the square root of 3. What angle do we think? We think negative pi over 3. Let's look at it. Negative pi over 3. So that one's down here, right? Ooh, that was kind of a bad color choice there, but that's okay. Negative pi over 3 has the coordinate 1/2 negative square root of 3 over 2. Okay. Now tangent of that would be my y value divided by my x value. And if I keep change flip, the 2's are going to go away. So I would get negative square root of 3. So we're close.
I hate this.
But instead of choosing that one, which one do you think it is?
The other one.
The other one. Pi over 6, right? Negative pi over 6 here is the square root of 3 over 2, negative 1/2. Okay, if I take my y value, divide by my x value, those 2's go away, and I end up getting the -1 over square root of 3 piece. So this is, in fact, negative pi over 6. So we're on the inverse properties of trig functions, because now we're going to evaluate composite functions using trig functions. So we're going to do the inside part first and then evaluate the outside piece, basically, okay? But this whole inverse properties is basically saying if I have an arc and a regular trig function right next to each other, those things can cancel out as long as it is in that domain, okay? So we're going to start out with sine, okay? If we have from -1, oh, that was weird, to 1 for my x values, and from negative pi over 2 to pi over 2 for my y values, then if I took the sine of the arc sine of something, I would end up with that something on the inside, okay? Because the sine and the arc sine would cancel each other out. Okay. If we had, again, from -1 to 1 and 0 to pi, then our cosine of arc cosine is also just x. This is just repeating those, again, those domain restrictions on your unit circle. And lastly, for tangent, if x is a real number, anything from -infinity to infinity, and we're in between -pi/2 with not a line underneath it and pi/2, then tangent of arctangent of x is equal to x. We are going to cross out example 11. Okay. So example 10 says find the exact value of cosine of arc cosine of -0.4. Well, I've got cosine and then I've got arc cosine right next to it. Those two things are going to cancel each other out, and we're just left with -0.4. It's not always that easy. Okay, sorry. Again, we're always going to do the inside function first and then the outside function if we can't just cross them out like we just did. Okay, so we're not going to do example 11. We're going to move on to the next page. So example 13, when I'm looking at the inside most parentheses there of that -√3/2 or that 2/3 or that 1/2 and those things, this is what we're looking for on the unit circle, okay? This -√3/2 is that value, or sorry, what did I say? No, we are going to do it. We're just doing 13 first, yeah. The -√3/2, is there a sign value on the unit circle that gives us that value? Yes, this is a familiar angle. It is on the unit circle. Okay, so if I think about the unit circle, draw ourselves a little picture here. No. If I'm looking at the unit circle, my y value, again, for arc sine happens in these two quadrants here. Okay, so my answer has to be in those two quadrants. And I'm looking at the y value. Of those unit circle values, which y value is -√3/2? -pi/3, right? It's going to be this point right here, which we'll call -pi/3. Okay? And again, that coordinate point is 1/2 -√3/2. So now we just evaluated that inside piece, the arc sine of -√3/2. The angle that gives me a value sine -√3/2 is -pi/3, right? So I can replace the inside piece with -pi/3. And now can I evaluate just cosine of -pi/3? Yeah, well, what's cosine of -pi/3? 1/2. So start with the inside piece, evaluate that, and then evaluate the outside piece. Okay? That's for ones that are familiar that are on the unit circle. Now, if I look at the rest of these values here, this 1/2, this 2/3, and this 12/5. with this like respective trig function, so like this is arctangent, this is arccosine, this is arctangent, are those values that are going to be on the unit circle? No, they are not. So instead, what we're going to have to do is, if it's ever an unfamiliar tangent, or cosine or sine, whatever it is, if it's unfamiliar, if it's not on the unit circle, we're going to just do a little right triangle trigonometry, okay? So this entire thing right here, I'm going to let that equal y. Okay, I'm going to say this is y, and I'm going to write out this equation. Okay, y is equal to that thing.
Okay.
So now technically I have sine of y, right? But let's just solve this. How could I get rid of an arctan? Tan on both sides, right? If I take and multiply, or if I take the trig function tan and apply it to both sides, I'm going to have tangent of y, tangent of arctan, that goes away. And now I just have tangent of y is equal to 1/2. Now you're asking yourself again, what is a y value, or sorry, angle that's going to give me a value of 1/2? Well, I don't know, but I could set up a triangle where that's a right angle, pretend, and then I'm going to call this y. Okay, if that's my angle y, and I know that tangent of y is 1/2, I could put a 1 here and a 2 here. We agree? And then could I find that missing side length? Yeah, 1 squared plus 2 squared would give me 5. So then this side would be the square root of 5. Okay? Now, the evaluation that we actually need to do is sine of y. Well, I know where y is in my triangle, so can I just find out what sine of y is from that triangle? I sure can. So sine of y would be opposite over hypotenuse, so this would equal 1 over the square root of 5.
Is that just another way to do it?
So this answer right here, sine of arctangent of 1/2 is equal to 1 over the square root of 5, or the square root of 5 over 5 if you rationalize it, okay? Ooh. Okay, let's look at example 14. Okay, again, if I look at the 2/3 on the inside, there is no cosine angle, or an angle that's going to give me a cosine value of 2/3. So I need to set up a little triangle. So this thing right here, I'm going to let that equal y. Oops. Y equals arc cosine of 2/3. If I take the if I take the cosine of both sides, the arc cosine and the cosine are going to go away, and I'm going to be left with cosine of y is equal to 2/3. Okay, so that right there tells me enough information to draw myself a right triangle. And in that right triangle, I'm going to label the side length y, or angle, sorry, the angle y. And then if it's cosine, it's adjacent over hypotenuse. So I'm going to have 2 here and 3 here. Okay, so from there, can I do a little right triangle Pythagorean theorem there? Square both of these and I subtract. What's this side length going to be? Square root of 5, right? This would be 4 plus x squared is equal to 9. So this would in fact be the square root of 5. So then what we actually have is tangent of that y piece, right? This y is what we just evaluated while using our triangle. And now I can just find out from this triangle what is tangent of that angle. Well, tangent is opposite over adjacent. So this answer would be square root of 5 over 2. So this entire thing right here is equal to the square root of 5 over 2. All right, this one is going to have the use of a double angle identity in there. Okay, so we are going to still do the same thing. We've got arctan of 12/5. Again, that 12/5 is not on the unit circle, so I'm going to let that piece be y. And if I took the tangent of both sides to get rid of that arctan, then I'm just left with that tangent of y is equal to 12/5. So if I drew myself a little triangle, I've got my angle y, and then opposite over adjacent. So what's my hypotenuse going to be? This is a Pythagorean triple, if you remember. 13. Okay, so since I let that piece be y, we are technically evaluating sine of 2y, right? There's a 2 in front of it. Well, do I know that formula? Sine of 2y is equal to something from your gold sheet, right? This is equal to 2 times sine of y times cosine of y using your identity number 24. So then from here, I can find, okay, sine of y from this angle right here is opposite over hypotenuse. So this becomes 2 times 12/13. And then if I had cosine of y, cosine is adjacent over hypotenuse. So that would be 5/13. And if I multiply across 2 times 12 times 5, that's going to give me 120/169. I do not believe so. So that is your final answer. Okay, if you look at these two pictures here, this is talking about inverse cotangent. So this is your cotangent function right here. This is what it looks like if you restrict the domain, just like we did for all of the, tangent, cosine, and sines. You would get something that looks like this here for my inverse function. Okay, so your inverse domain and range are negative infinity to infinity, 0 to pi. And then on this page, it shows you the arc secant and arc cosine. Arc cosecant, not arc cosine. Again, it shows you the region that it's restricted to, but the really helpful picture is this right here, okay? This tells me that from negative pi over 2 to pi over 2, that's where my arc sine, arc tangent, and arc cosecant values should lie. From 0 to pi, that's where my arc cosine, arc cotangent, and arc secant should lie, okay? So this is definitely something that I would highly recommend to draw on your note card for your test. We're just going to write it right here. If I asked you to evaluate secant inverse of the square root of 2, okay? This one we could do without a calculator. If I rewrote secant is what? 1 over cosine. We're not going to write it 1 over cosine inverse of the square root of 2. That's not going to work, okay? You're going to write cosine inverse of, and then in the parentheses, you've got your 1 over the square root of 2 piece. Okay? Because otherwise it's not going to work. This was on if you guys remember back two units ago, I think, this was a question on your, not this exact one, but there was a question very similar to this on your test, and a lot of you guys did 1 divided by cosine inverse of the entire thing, but you needed to just do 1 divided by that inside the parentheses part, not the actual cosine inverse in the denominator. Okay? Do you guys agree that this is also the same thing as cosine inverse of the square root of 2 over 2, technically, right? So then square root of 2 over 2, think what angle is going to give me a square root of 2 over 2 for cosine. So if you look at your gold sheet, where do I have square root of 2 over 2 for arc cosine, which means that we need to be in the first or second quadrant? Pi over 4. Okay, does that make sense?
So the whole thing is pi over 4.
That whole answer, yeah, pi over 4. And then the last one's just a calculator. Make sure we know how to use our calculator. So if I asked you to find the cosecant of 2.49371, okay, what is the reciprocal of cosecant? sine, right? So I'm not going to do 1 over sine inverse. It's just going to be sine inverse of 1 over 2.49371, because there is not a cosecant inverse button on your calculator, okay? And then on your homework, on your test, it should tell you whether it should be in radians or degrees. Let's just practice doing both, so that way we have both answers, and we know how to change our mode if we've forgotten. If you did degrees first, you should get 26.64 degrees. Should be. Or did you do radians first? What did you get?
I got 23.64.
Sorry, it is 23.64. And then if someone would tell me what they got in radians, I remember it's like 0.4 something, but I don't remember. 4126. We'll leave it as that. And that's in radians. Okay.